Hi there. This is Stephen Fields, and I just wanted to give a brief overview of what I've been doing for the past couple weeks for my independent study. So, this notebook here, I will provide a link to you guys as well. It's called Paper Trail. My original thoughts for it are I want to weight the references in order to um, score them on similarity and then weight them based on that similarity in order to try to give like a good idea of what to read or maybe like what's more important to read and a couple papers to read beforehand. Um, so here's just imports and some parameters. I created this data structure to hold in some of the attributes that I need from OpenAlex. And then it also can give you a query to get the references and related articles. Um, this will take the result JSON for a particular article, and then actually turn it into the data structure below. I restarted it, so I should have been running all of these. So from here, we search for a title. I will choose one that I've already done to kind of minimize the time it takes to find all of the related articles. So this one should pop up nicely. And then I provided, so this will search the works endpoint for and then I take the top 25 and make it a drop down. I think it's 25. I might be wrong about that. I don't remember. But then it'll go through. This gets the root ID, so the attention is all you need. This will get that paper. Here we get all relevant papers, and it's based on these two booleans up here in the parameters. So if we want to ignore related works, which I believe OpenAlex did their own similarity matrix for OpenWorks, and that's what's here. And then it'll also ignore referenced for some reason if you want to do that. But then based on that, the way it's currently set up is it will get all of the references. If no references exist, it will get the related articles. And I had to implement it that way because for attention is all you need and a couple others, they don't have the references listed on OpenAlex in the API. So I had to resort to using the related for at least that paper. So basically, any paper that doesn't have references, we will use OpenAlex's pre-calculated related articles. Um, so yeah, this generally takes about 20 seconds, 20 seconds to a minute to get through. Once all the papers are fetched, we initialize the model. Thanks to YY, I've been using this OAG-BERT, which is Open Academic Graph BERT, I believe. So for each paper we get back, we create the inputs for it using a bunch of the data we received from OpenAlex. We get the embeddings here, and then currently we just save them to a file. Not best practice, but it prevented my RAM from blowing up every time I tried to run this. This should be fairly quickly because I've already ran it for this paper, so all of them are stored in this nice large folder. I believe there's like 400 papers. Let's see, papers. 300 papers. Okay. I think it's 400 if I use the related. And then here, after we have all of these embeddings files, we calculate, we would load them in. First, we load in the root papers embeddings. We get a list of all the keys minus the root ID. And then we create a data frame containing the paper's ID, the title, and the score and its comparison to the root paper. So for this one, it's the attention is all you need paper. Here we load in each embedding to compare to the root, and then we normalize and calculate the similarity and append it to the data frame. And this actually works a lot quicker than I would expect. If you already have them all, it takes 0.1 seconds, and that's reading in 300 different files. So I actually expected that to take longer than it does. Here, we're just printing out the 25 most similar papers. So we can see LSTM, word representations, deep contextualized word representations, a couple BERT papers which rely on transformers, obviously. So it does give some decent results. And then here I have printed out the paper. Well, I haven't yet. This is for the black holes. For these two, I print out the root papers abstract and then the 5 most similar papers abstracts. That's where I'm at currently. I've been working on this specific notebook for about a week now. There are some things I want to change. Firstly, this is just comparing all of the papers in the list to the root paper. I want to kind of create a bias so that so the papers at the first layer, think of it like a tree. There's the root, and then there's its relevance or references and related articles, and then the relevant articles for all of those referenced articles. I want to bias it somehow so that a level 1 paper reference will have like a heavier score or a greater score if its referenced papers are related to the topic of the root paper. So I'm trying to figure out how I want to do that right now, because it gets a little tricky with the math. And then other than that, I want to look into using a vector database. So rather than saving all of these embeddings to a file output, I want to use something like this. I haven't really tested it yet. This is just one of the first ones I found, so I'm reading the docs currently. I'm going to look at a couple others, but it saves. You can create, I hate that about this website. You can create a float vector and give it a number of dimensions, and then you can just read it like you would from a database normally. I want to try that out. That sounds like a much better idea than saving them all to files. But that's where I am currently, and I think with the next week I'm going to try testing out one of these vector databases and give some thought to how I want to bias the papers to improve their scores based on how relevant they are and how relevant their references are. As always, open to feedback, and thanks.